In some ways, the application of water onto a fire has changed little over the years, but one fact remains constant. How we develop our firefighting streams has always had a great effect on the outcome of the call. With the help of many new and different technologies, we have greater capabilities than ever before to safely and efficiently attack and kill fire at its worst. As modern-day firefighters, we need to learn from our past so we can better serve our citizens. To ignore the lessons of the past will only have a negative effect on our safety and perhaps our future.
Hi, I'm your host, Larry Davis, and I'm out here in Michigan at the Allendale Fire Museum, where we want to take a look at the evolution of the fire nozzle. I've been involved in fire service since back in the mid-1960s. Many of you know me as the former chairman of ISFSI, the International Society of Fire Service Instructors, and the author of Rural Firefighting Operations Book 1, 2, and 3. With all the changes that have occurred, sometimes we lose sight of the primary mission of the fire department, which really is fire attack. In selecting nozzles for fire attack, there's an awful lot of confusion and misinformation out there today. Many of the people charged with responsibility for selecting nozzles are doing so based on rumors or misinformation or just really unfounded facts. Problem is, if we screw up in nozzle selection, not only do we risk our own safety, but we also jeopardize people and property. Before we get into that part of the program, however, let's first take a look inside at this fire museum. Hi, Jeff.
Hi, Larry.
This is Jeff DePilka. He and his staff at West Shore Services operate the fire museum here. Jeff, I was thinking maybe you could give the folks a bit of an idea of how this museum got started and came about.
Sure, Larry. In 1980, when the building was 100 years old, the fire chief in Grand Rapids informed us that this building was going to be torn down, and I think his comment was going to be landfilled in 2 weeks. They were going to build another building on the same site that this station occupied. So I got a bunch of folks from our company and friends of mine together, and we approached the city about taking this building down and moving it here. And
so you moved it how far?
We moved it about 20 miles.
And totally reconstructed it?
Yes, we had to take it apart literally brick by brick. It took us 10 weeks and 2 days to take the station apart, but it took about 4 years to put it back together, and we opened in 1986. We've tried to collect something for everyone. We've got a varied collection, everything from fire apparatus through nozzles and buckets, lanterns, trumpets, pretty much a broad range of fire memorabilia. On the main floor, we've got 5 pieces of motorized apparatus, 2 Aaron's Foxes and 3 American LaFrances.
And it's all operational, isn't it?
Yes, it is. I probably got started in fire apparatus collecting or fire memorabilia collecting with the nozzle was probably what sparked my interest. We've got a large collection and a very varied collection. You don't see a lot of nozzles, too, of the same kind.
Thank you very much.
You're welcome, Larry. If there's anything you need, let us know. Make yourself right at home.
Great, thanks.
You bet.
For the best information on nozzles and fire streams, we're going to be talking to Stuart McMillan, president of Task Force Tips and a multi-generational firefighter. I've personally known Stu for over 20 years. Hi, Stu. How are you?
Hi. Welcome to Michigan.
Thanks. Nice to be here. Thought maybe we'd take some time at the beginning to set the stage for the purpose of this program and what we want to accomplish.
Okay. Well, as you well know, Task Force Tips has been a leader in education for many years in the fire service. And what we've noticed happening the last few years is that there's been a lot of misinformation about fire nozzles and fire streams. And we're finding firefighters to be more and more confused. Firefighters are a lot busier with a lot of things these days, and they don't have time for the nozzles like they used to.
Sure.
So what we've done is come to this museum in Michigan where we have access to many old nozzles and the new nozzles, and we can study the different types and help firemen.
Kind of show a timeline of how they're developed.
So to speak. Exactly. Speaking of timelines, I was noticing this old truck before you came. Here's a 50-year-old Aaron's Fox, but things haven't changed. We still have water going in and water coming out of a pump and a pressure gauge to measure it.
That's amazing.
So for all the technology we've advanced, we're still doing water delivery basically the same way we always have. Let's go upstairs and look at some old nozzles.
Sounds great.
Okay.
You know, Stu, I've been training fire departments, I guess, probably since back in 1970. And remember when we started off with nozzles like this, and today we're up here to the state of the art. And I think one of the biggest problems from a fire instructor standpoint is helping a young firefighter today understand how we got from this to this. Thought maybe you could share some historical developments with a timeline of how nozzles came about.
Well, actually, it all started back even before the 1870s with the bucket. But firemen quickly realized that they had to get a lot more flow on the fire and with fewer manpower.
Sure.
And we're going to see that that theme carries through all these different nozzles. In fact, there's several themes. One is maximizing flow. One is maximizing control. And the third theme is how to give different patterns to the firefighter.
Yeah.
At its basic roots, every single nozzle here does one thing.
What's that?
Provides an orifice.
Uh-huh.
There are all different ways of providing an orifice. An orifice provides pressure so that the fireman has an effective stream to do his job. One thing that's rather unique about this nozzle, you'll notice it has no shutoff.
Yeah. Is that just because, I guess, when it was invented, they really didn't have a convenient way of shutting it off?
No, actually, they had shutoffs. The problem was these pumpers were positive displacement pumpers, piston pumpers and gear pumpers with leather hose. And if a fireman were to shut off that type of nozzle, the pressure would go right up and the hose would burst.
Sure, just like water hammer, I guess.
So they didn't have much control at all back in those days. Once the relief valve came about, they moved to a nozzle that had a shutoff on it, but still the pattern was limited to one of being straight stream only. Many firemen have heard the term combination nozzle, and from the looks of this pipe right here, this might be where the terminology started. It says combination nozzle on there.
So you can actually direct the flow either through this side or through this side with these combination of
Exactly,
valves.
but not both at the same time. So this is a spray straight stream nozzle. This is a nozzle that was patented in 1892, a very innovative way of providing a straight stream again, and a fog that would form the water around this ball.
Isn't that interesting?
Not much development took place then until approximately 1940. This is a booster-sized nozzle of the famous Rockwood nozzle built for the U.S. Navy.
I've heard some people call that the Navy nozzle. I guess that's
Exactly. Most any fireman that ever had any Navy firefighting training used a nozzle of this type. And it had an orifice on top and a spray nozzle that also could be used with applicators.
Well, how did you switch from one to the other with this one?
Well, I believe the shutoff had different positions.
Oh, I see. Yeah.
But up to this point in time, we still have one major problem. All of these orifices are one size. Once the firefighter went to work with a particular orifice,
yes,
he was stuck with it.
So he couldn't increase the flow, really.
Exactly. As time went on, here's another attempt at providing a fog pattern and a straight stream. And here is what was frequently called a mystery nozzle.
Oh, yeah. Yeah, I remember that well.
Okay. And this had a straight stream and a fog combined. They could control the flow and the pattern. There's one big problem with this type of nozzle, and that is the time you needed the pressure the most is in fog. And yet the orifice on this nozzle gets larger in the fog position.
I see.
So the pressure goes down when you need it most. It was this nozzle that led to one of the most misunderstood terms in the whole fire service.
It is. What term was that?
Constant gallonage.
Ah.
Constant gallonage. This nozzle is not constant gallonage. And what constant gallonage means is with pattern. And many firefighters believe that a constant gallonage nozzle means it only flows one flow.
Sure, sure.
Not true. Constant gallonage means that when you change the pattern, the flow stays the same.
In other words, whether it's a wide fog or a straight stream, it would be the same flow.
Exactly.
Where the mystery nozzle didn't do that.
Which means that nozzle pressure stays constant in fog or straight stream, so you didn't lose it. And this evolution to the constant gallonage type of nozzle took place about the 1940s, late 40s, early 50s. But still, single-size orifice, no control.
Sure.
Whatever flow the firefighter went to work with, that was the flow he was committed to.
The only difference really between this and a straight stream is that you could change the pattern on this. The flow would remain constant, but the pattern would actually change.
Correct, exactly. Which was much quicker than going starkly from straight stream to fog as these nozzles did in the early attempts. So it was a vast improvement over what had been available before that time. So we have this type of nozzle being developed in the early 50s. What people quickly found out, though, was they were stuck with one flow, one pressure. And they knew they needed to have more control than that. Remember, control is a theme all through this whole evolution of nozzles. So the next thing they did was a way to control the baffle, the orifice out here in front. And what this does is moves that baffle in and out to change that orifice size from a small nozzle to a large nozzle. Still constant gallonage.
Yep.
Every modern-day fog nozzle made is a constant gallonage
And that
nozzle.
means that the flow in terms of gallons per minute is the same as whether it's a wide fog or a straight stream.
Exactly, and that's very important to understand. It's very misunderstood in the industry.
So this is really, I guess, a variable gallonage nozzle where you can actually select this stream and
Manually
also
select it.
variable pattern.
Right. The problem with this, however, is a matter of coordination. Who selects first, the nozzleman
Sure.
or the pump operator?
Sure.
If the nozzleman selects a small flow early on, the pump operator achieves his pressure quite quickly.
Sure.
He thinks everything's fine. The nozzleman tries to go to a higher flow. How does he get that pump operator to coordinate with him? So
Sure.
that you have a big coordination problem. As we know on fire grounds, we don't need any more problems with coordination than we already have.
That's for sure. We've got enough confusion already.
So this is where an automatic pressure control comes into the picture. My father was using this type of nozzle in master streams in Gary, Indiana in 1968, and he realized one morning at breakfast that he could take the simple device of a spring and move that baffle back and forth in response to the water flow. No longer would it be necessary to manually control that flow. It could be done automatically. And in fact, since we're in a museum, thought I might show you a little piece of history here. This is the actual napkin that the automatic nozzle was invented on May 10th of 1968. So from that point on, this was primarily a master stream thing because master streams are where the real flow problems occur first.
Sure.
So early on in the 1972, 73, we investigated putting an automatic pressure control into a handline nozzle. Thing happened where we got involved with Syracuse, New York.
Oh, I remember, sure.
Syracuse, New York was experimenting with rapid water,
Yep.
1.75-inch hose,
Mini maxi pumper.
mini
pumps.
maxi pumpers, exactly. What they were looking for was a way of giving higher flow capability to their firefighters and yet leaving them in control.
Sure.
And all of a sudden it came clear that an automatic nozzle could be coupled with the valve to give flow control capability to the firefighter. Now the problem with that design-wise is a ball valve has turbulence,
Yes.
a lot of turbulence. And so in the initial design, there was a little ringer put here. You can see that moving back and forth.
Oh, yeah.
And that was tied to the baffle.
Uh-huh.
So as the firefighter was controlling the flow,
Yep.
this ringer was taking out the turbulence. And what he got was a nozzle that he could control the flow from any maximum, which was set by the pump operator, down to the nozzle being shut off, the entire time maintaining a clean pattern.
Sure.
So this is sensing the water pressure at the front. The spring that you see here on the table is now inside of this.
I see.
And that spring is, again, just like that thumb on a garden hose, controlling the orifice. So
And
you
as
get-
they increase the pressure above 100 pounds, this will begin to open, so it opens up the waterway and lets more water flow.
You got it. That's exactly right.
Interesting.
And there were several variations on that. This is the Elkhart SM30 series, also a spring design nozzle, achromatic. Now Akron did something on this. They didn't have the turbulence control, so they put a volume control ring. Now what this volume control ring did was pull back on the baffle. See the little linkage down in here?
Yes, sure.
That linkage pulls back on the baffle. This was sold as flow control. It's really not, because what was happening is you're overriding the automatic pressure control.
I see.
You're pulling that baffle back manually. You're overriding the pressure control. The nozzle pressure would go up. The only way to have true flow control is to gate it with the valve and use the valve to make extra restriction in the line.
Sure.
And let the automatic pressure control do its job. So this nozzle was not real successful in the marketplace because of the difficulty understanding its operation.
That's all we need is more complexity. Well, Stu, I guess we've pretty much covered all the history of nozzles up to the present. What we need to look at now is where the state of the art is in nozzle technology.
Well, the current state of the art would be an automatic nozzle, such as this, with a flow range that's wide enough to cover your pre-connect and hand line sizes. And the valve has evolved from being a ball valve, as we saw in all the previous designs, to one of being a slide valve, which is much like a needle and seat. And the true beauty of this valve is that as the firefighter controls the flow by moving this back and forth with the bail, there's no turbulence created. So the automatic nozzle can maintain that pressure at 100 psi, delivering the stream.
It's really a lot like a relief valve, isn't it?
It's exactly like a relief valve. This mechanism operates just like the relief valve we saw down at Aaron's Fox.
Well, let me ask you this. If I had this nozzle, and basically this nozzle is designed to operate at 100 pounds nozzle pressure, and as line pressure goes up above 100 at the nozzle senses that and opens. What happens if I don't have 100 pounds pressure, say, at the nozzle?
That's an excellent question. This particular nozzle would have a minimum orifice of about 50 gallons a minute. To deal with that exact problem, there's a different type of nozzle that has a pressure control override. Now, some people think this is a really new development. But if you'll hand me that nozzle there from the 1970s, the early TFTs had a flip spin flush on them that was actually marked override. The problem was people got confused by this.
I'm sure.
They'd sometimes put it in override and really go all the way to flush. The water kind of fell on their boots and had a problem.
So this would allow, even if I had less than 100 pounds pressure, by putting this in the override, I'd get enough flow out of it to be effective.
Exactly.
Same thing with that new nozzle.
Yes, this lowers the nozzle pressure to where it operates about 50 psi. It still is automatic, but it lowers it to about 50 psi. This mechanism actually overrode the automatic, so it was no longer functional.
I guess the issue that I think about, it seems to me that other than some kind of catastrophic failure, I should never have less than 100 pounds pressure. And if my pump operator is paying attention to the line, he should make sure I've got enough engine pressure to guarantee I've got 100 pounds nozzle pressure.
Firemen are never hampered by a lack of pressure.
Yeah.
They're hampered by a lack of water.
Yeah.
And the proper size orifice to use that water.
Sure.
Any modern day pumper can develop any pressure needed on the fire ground if the proper orifice is there so the pump can develop pressure.
Sure.
What too often happens is the orifice is too large, there's not enough flow to fill that nozzle, and the pressure then is low. This prevents that from happening by giving you the correct orifice all the time, automatically. Much like an automatic transmission makes driving a modern day fire truck a much easier task.
Certainly does. You know, Stu, in looking at recent fire service history over the last, I guess, 25 years, we went from solid bore straight stream nozzles to the combination nozzle where we had a constant gallonage, and then we went to the automatic nozzle where we had a nozzle that would open up and give us more flow. I've always taught people we want the most flow from a nozzle that we can get, but in many cases it seems like we're not really utilizing our resources to the maximum.
We do see a problem with that. And the problem seems to be related to the fact that not every fire is a big fire.
Yeah, in fact, most are small.
Exactly. Most of them are small, so what's happened over time is the pump pressure gets gradually back down to where maybe someone's operating an automatic nozzle, 120 pounds, 110 pounds. Still has a good stream, still has a very small flow.
Yes.
The big fire comes along, they make their attack, they're not getting a headway on it. So what do? They switch to a smooth bore nozzle or a low pressure nozzle. All of a sudden the flow comes back and they make the attack. Unfortunately, they drew the wrong conclusion. The conclusion they drew was the nozzle made the difference, when in fact they upped their flow by going to a low pressure nozzle. Had they instead just bumped the pump pressure back to where it was when they bought those new nozzles, would have had the same effect.
Sure.
We can't forget the water puts the fire out, not the pressure. And so we have to get our pump pressures up to where we cover those friction losses to get that flow out of that nozzle at 100 psi.
As I sit here and look at this antique that we're sitting here next to, I look at this smooth bore nozzle. In recognizing the fact that fire departments like New York City are using a 15/16 straight bore, which in reality is very similar to this, but they operate a lot differently than most fire departments.
Yes, they do.
And I see other fire departments that have gone to a nozzle like this, which is a low-pressure nozzle designed to work somewhere around 75 pounds, I guess, versus 100 pounds. To me, that almost seems like we've taken a step backwards. We're moving back towards this instead of using the technology and the apparatus and equipment we have to our maximum.
Very true. A lot of fire departments are afraid to bring the pressure up. Modern-day hose is tested to work well above 200 psi as a working pressure. It doesn't kink at high pressure. It's not hard to bend like it used to be. And one of the problems, and this may seem a little bit funny to you, but we have firemen today who are used to air-conditioned automobiles.
Sure.
They haven't stood next to a pumper working hard at a fire. They haven't driven next to a semi going 55 miles an hour and heard that noise from that engine. They get to the fire ground, they hear the loud noise, and they think they're overworking the truck.
Sure.
If they were to actually get out and compare that tachometer, they'd see that that truck could go that speed for 250,000 miles and not wear out. But we're not accustomed to that kind of noise level.
So basically, people just aren't operating pumps at the pressures they really should be. Instead of increasing the pump pressures to give me more flow, what they have done is they've gone to a bigger nozzle, or a nozzle that operates with less pressure and run it at a lower RPM.
I like to draw the comparison to police officers of the United States. They're worried about fighting criminals with bigger guns and bigger weapons. What would happen if a police officer went out and took all the powder out of his bullets?
Yeah.
That's what we're doing. We're telling our firemen, go to a lower pressure, take the powder out of your bullet, instead of getting the pressure up to where it has reach and impact and action like we had in days gone by here in the recent history. So we want to get those pump pressures back up, get the flows back up. New York City, of course, operates quite differently in that they arrive with a truck company and several engine companies. Incredible staffing. We can't get ventilation early on like New York does. We don't have the water supply New York does. We have to hit it hard, and we have to have control over that line. And an automatic nozzle allows our smallest firefighter or our largest firefighter to at least be able to work that stream to his or her maximum potential.
And whatever water I have, as long as I've got the 100 pounds nozzle pressure, I'm going to have an effective stream.
Right, and they can use that valve to control it.
Yeah.
So we're advocating control of the stream through using the valve with a nozzle that has turbulence control and using an automatic to keep that stream pressure where it belongs.
Stu, let's get back to the issue of the smoothbore. Maybe not so much just on hand lines, but on master stream devices. I know you're not a big advocate with smoothbore and master streams, and I'd be interested in your take on that.
Well, I think where the controversy starts on that is attacking a fire with a fog or a straight stream. We feel that a fog nozzle, combination nozzle, develops an equivalent straight stream to a smoothbore. Where this really starts is back in 1955 when my father was fighting a fire at the Whiting refinery, and there was a large tank of naphtha blew up. He was on a smoothbore nozzle. He had to crank the gun up, couldn't do it fast enough, and got severely burned. He was over a year recovering from that.
Just simply because he couldn't widen a fog to
couldn't
give
get
them
a
some
fog
protection for their people.
Exactly, and he tried to run, and you can't outrun a fire. At that point in time, he pretty much swore off on ever using smoothbores, and in fact, it was the reason that he was using fog nozzles in the early 60s that he developed the automatic nozzle, because you didn't have a stacked fog nozzle at that time.
Sure.
The other problem with stacked nozzles is if you go through any fire magazine, any buff magazine of any city in the country, you'll always see the smallest tip being used.
Yes.
The 1.5-inch tip. They go to work with that. That's the initial stream. And everyone's a little bit concerned that if they shut down and take it off, will there be enough water available for that next size tip? So what happens is you have a 1,000 or a 1,250 or a 1,500 gallon a minute pumper delivering 600 gallon a minute.
Sure.
Had that been an automatic nozzle on that master stream, it would have gone up to whatever capacity was available, and as hand lines were taken off or as they cut back on it later, the nozzle would readjust correctly.
Sure.
But all the time they would have had a properly pressured stream with no user intervention. And that's where, to a lot of firemen, we're taking the tool away from them by giving them only a straight stream nozzle. We're taking away the protection, we're taking away the ability to ventilate, and we're taking away the ability to use that narrow fog pattern in the overhead to take out just enough heat to make entry to the fire, and then use the straight stream on the seat of the fire to get extinguishment.
Yep.
So we're trying to teach firemen how to use the tool instead of taking the tool away from them.
All this, the talk about low pressure combination, low pressure fog nozzles. you guys are involved in the manufacture of low-pressure nozzles for fire departments that want them. Is that correct?
Yeah, that's absolutely correct. In fact, we've been manufacturing not only selectable gallonage nozzles, but fixed gallonage nozzles for approximately 10 years. And there is a place for this type of nozzle.
Sure.
Industrial applications or fixed flow applications, it's perfect. We kept the nozzle under the KK name because we were very concerned that firemen would confuse this as being the latest thing from TFT.
Sure.
And we didn't want that to happen because for primary fire attack, an automatic nozzle is still the most current technology available to the firemen today. But we want to be very careful that we don't push firemen in a technology direction that takes them backwards instead of forwards.
Mm-hmm.
And
Which
this
in
type
essence,
of
that does.
yes,
I mean,
about 40 years.
The nozzle has a pistol grip, but I mean, I grew up on a nozzle like that in the early 70s. It was, you know, a variable pattern, but essentially constant gallonage.
Single flow attack. Exactly right. It's a 40-year-old technology nozzle with a new wrapper on it.
What's going on in the marketplace out here today? Not just TFT, but looking at other nozzle manufacturers.
Well, clearly TFT is still promoting flow control automatic nozzles for maximum firefighter control. Unfortunately, what we see our competition promoting is, for example, the Elkhart Chief or the Akron Assault, both nozzles that are clearly manual single gallonage nozzles from 40-year-old technology. What I'd like to read to you is a short excerpt from an Elkhart ad from the 1970 Fire Engineering magazine. It says, "It is not a lack of pressure that creates a poor stream, it's a lack of water. Any modern pumper can supply any desired pressure, but it cannot manufacture water. This was the driving idea between the Adjuster 100, a nozzle that uses the water available for consistently effective streams. 30 years ago, Elkhart was promoting automatic nozzles as the latest and greatest thing on the market. Today they're promoting a nozzle that was developed years before it came on the market."
Stu, what kind of resources are available to help answer questions for instructors or firefighters regarding the nozzle selection?
We have many available. Probably our most important first place to go would be our distributors. We have some of the best informed distributors in the country. We also have what we call our Hot Fax site, which is a 24-hour available fax robot which has many technical bulletins on it. We also have our website, but most importantly, we have people at the end of the phone line that are willing to help. And 24 hours a day, our 800 number rings at both my home and my brother's home, and we're there to answer questions. And since Doug and I have both been involved in firefighting for a long time, we can relate in fireman language what it's like being in there, and we know how the nozzles perform under actual conditions.
In this video, we've tried to give you some information to help eliminate some of the confusion when it comes to the selection of nozzles. In future segments, we're going to cover a lot more detail about how to get the wet stuff to the red stuff. Most important thing to remember at this point, though, is when it comes to the selection of nozzles, you're in the driver's seat.